All right, let's take a look here at 57. And the word problem they've given us says a rectangular garden is 12 feet by 5 feet. A gravel path of equal width is to be built around the garden. How wide can the path be if there is enough gravel for 138 square feet? All right, so I went ahead and before I started recording, I sketched out this little diagram to save us some time. And so we have a garden with a dimension of 12 feet by 5 feet. And then around this garden, we're going to build a gravel path. We don't know how wide the gravel path is. That's actually what we're trying to find, right? How wide can the path be if there's enough gravel for 138 square feet? Well, what we're going to do here is, since we don't know the width of the path, let's go ahead and try to set up an equation that's going to help us to solve for that. So we do have a bit of information here. Right now, we can find the area of just the garden itself, right? Because we have the dimensions of the garden, 12 by 5. So the area of the garden here is, again, this is a rectangle, right? So it's just length times width. And so in this case, the area of the garden is just 12 by 5. So in this case, 60 square feet. And now if we add 60 square feet, which is just the area of the garden, plus the area of what the gravel path is going to give us, so 60 plus 138, let's go ahead and put that into a formula to help us solve for x, which is going to tell us how wide the gravel path itself is. So again, we're going to use length times width, but now we're going to be using, because we don't know how wide the path is, we're going to be using 12 feet, which is the width of the garden, plus this x, and plus this x will give us our length, our new length, including the gravel path. So when we are doing our length times width, now we're going to say 12, which comes from the garden, plus 2x times, now 5 feet, times, well, we don't know how wide, again, this path is, so x and x, so 5 feet plus 2x equals, well, now 60 feet, and that comes from the area of just the garden, plus 138 feet, which is the total area of the path. And now we have ourselves an equation where we can hopefully solve for x, which is going to tell us just how wide this path is. So, knowing what we know from previous videos, let's go ahead and try to get all of our terms on one side of the equation and set the equation equal to 0. But before we can do that, let's go ahead and FOIL the left side of our equation out to see what we get. All right, so we have 12 times 5, that's going to give us 60. And 12 times 2x will be plus 24x. And 2x times 5, that'll be 10x. And 2x times 2x will be plus 4x squared equals, and now 60 plus 138 is going to give us 198. And we can go ahead and combine some like terms. So we'll end up with 60 plus, and 24x plus 10x will give us 34x plus 4x squared equals 198. And lastly here, to set this equation equal to 0, let's subtract 198 from both sides. And I'll go ahead and write the new equation up here, and that's going to give us our quadratic equation that's set equal to 0. But I'm going to go ahead and write the equation in descending order of power. So we'll end up with 4x squared plus 34x. And now 60 minus 198 is going to give us minus 138. Now equals 0, right? Because 198 minus 198 is 0, so 0. And now here's the quadratic equation that we can solve or factor to find out what x is. All right, now we can go through our steps. We can go and say, all right, is there a GCF here? And it looks like there is, right? At least a 2, right? Because each one of our coefficients is even. But I think this is going to be an equation that would be easier to solve for using the quadratic formula. So let's go ahead and use the quadratic formula, and we'll go ahead and do it up here. So x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. And I don't think we've used this yet in the practice test, so I think it's a good thing that we're using it here, because you may very well see it on your actual test rather. And remember, when you're not able to factor something using the AC method or trial and error or the scissors method, the quadratic equation always works. All right, so we have to identify, let's go ahead and identify our A, our B, and our C here. So our A is going to be the coefficient in front of our x squared, so 4. B is going to be the coefficient in front of just our x term, so 34. And C is going to be our constant here, so negative 138. And now let's go ahead and put this information just into this formula. So x equals negative b, well, what's b? 34, plus and minus the square root of b, so 34 squared minus 4a c, so negative 138, divided by 2a. All right, let's go ahead and clean this up a little bit, and just so I can have some extra room here, I'm going to go ahead and get rid of that. All right, so we have x equals, well, negative times 34 is negative 34, plus and minus the square root of b squared. Well, 34 squared, I'm not sure. Let's go ahead and see what that is. So 34 squared gives us 1156. So we have 1156. And now we have negative 4 times 4. So this is negative 16 times negative 138. So that's going to give us a positive, but I don't know what it's going to be. So we have negative 16 times our negative 138. It's going to give us 2208. So 2208 all over 2 times 4 is 8. So cleaning this up still, we'll have x equals negative 34 plus and minus the square root of 1156. So 1156 plus 2208 gives us 3364, and hopefully that is a perfect square. All over 8. And again, running out of room here, so I'm going to go ahead and erase some of this. And I'll probably need this room down here, so let's be proactive and do it now. All right, and why not? Let's go ahead and just take this whole thing, move it over there. All right, so now we have some room. So x equals negative 34 plus and minus, and hopefully that is a perfect square. I don't know. So the square root of 3364 is, oh good, 58. Awesome. So 58 divided by 8. All right, so now we have some numbers that I think are going to work out nicely. So really, because this plus and minus, we have two answers, right? We're going to have x equals negative 34 plus 58 divided by 8. And then we're going to have x equals negative 34 minus 58 divided by 8. And if you go through here and you work this out, you'll end up with 3, x equals 3 over here. And if you go through and work this out, you'll end up with x equals negative 23 over 4, I believe it was. All right, well, again, we're trying to solve for the width of a path, right, a walkway. So we're talking about dimensions, we're talking about distance, how wide something is. So can we have a negative distance? Can a sidewalk or a hallway be negative 23 over 4? And these are really in feet, aren't they? That's the unit we were working with. No, of course not. We can't have negative distance, so we can go ahead and drop that answer completely, and the only one that we're left with is one that makes sense, right? That a path is 3 feet. Sure, that makes sense. And so there's your answer. The path, how wide can the path be if there's enough gravel for 138 square feet? Well, the path can be 3 feet wide all the way around. All right, so again, I think I mentioned at the beginning of the number 56, that word problem, that because this section is dealing with factoring and mostly quadratic equations, you want to look for, in your word problem, information that helps you to build a quadratic equation, which is exactly what we did right here. Once you have your quadratic equation, then go ahead and factor it just like we've been doing. In this case, we went through and did the quadratic formula. I didn't try factoring this through the AC or trial and error or scissors. It may work, but when I first saw this, I thought it would be easier to try and use the quadratic formula. But again, whatever way works for you. All right. So, and it's good to see this quadratic formula, and definitely try to know that, the quadratic formula, because if it's not on this test, it's certainly going to come up in college algebra and beyond. So it's a good idea to have it memorized now. All right, so there was number 57. Let's go ahead and take a look at number 58.